Do that. Let me redo that real quick. It's like, honestly, this is like filming a TV show. You know what I'm saying? Because it's kind of like, you got your cuts, you got your take twos, you got your editing, you know what I'm saying? It's fun. Okay. Hi guys. Hi guys, I'm Arielle-Cherie. Welcome to my channel if you haven't been here yet, and welcome back if you have. So today I'm going to be taking you guys on a lab tour, but before I do, let me talk about what lab we're in and how I got here. So this is a room for the interns that is a part of the Self-Organizing Systems Research Lab at Harvard University, and I got here through a program called an REU, which is a research experience for undergraduates. So basically, if you'd like to get research experience over the summer, you can Google REU, and there are a ton of programs that'll come up for different disciplines. It's not restricted only to computer science. Like, there are REUs for physics, chemistry, all kinds of stuff. And let me talk about what the lab does. So this is all new to me because I had an idea before coming here, but now that I've interacted with people who work in the lab and I've done research a bit, I kind of understand more about what a lab is. So what a lab is it's a group of people that work together to answer some sort of research question in their own field. And so there will be a person who's in charge of the lab in general, and then there will be postdocs, which means people who have already graduated with their PhD who work in the lab and get paid, and like that is their work, that is their career choice, you know what I'm saying? And then there are also grad students who work in the lab, and the projects that they work on count towards the credits they need to earn to get their graduate degree that they're working towards. And then oftentimes there will be undergrad students that work in the lab to help out the graduate students. So those are the kind of people that work in the lab, and year round that's what they do. Like, they just do research on whatever project it is they're trying to like come up with a solution for, and they test out different experiments and, you know what I'm saying, make refinements based off of that. And it's just like a continuous thing. Once people who work in the lab get to a point in their research where they feel really happy with what they've learned or what they've developed, then they can write a research paper, and then they can get it published. And then once it's published, they can apply to different conferences in order to present their research. So that's kind of like the path that researchers take. They like join a lab. It can be in academia, like a university. Many universities have labs. Or it can be, yeah, no, it's in academia, because I was about to say it can be in industry too. And industries definitely do have labs, but like what is discovered is company intellectual property, you know what I'm saying? So they're not going to publish papers and stuff on it. But yeah, so that's what happens in academia labs. Specifically though, this lab is a robotics lab. This lab focuses on swarm robotics. A swarm robot is just a group of robots that work together to achieve some sort of task. So the lab basically looks at nature and specifically studies collectives in nature, a school of fish, a flock of birds. They study these group behaviors and try to like mimic them with robots. Each of these species, like termites, fish, birds, etc., like they work in a group, but they're all working towards some sort of goal. Do you know what I'm saying? But the way that they work in the group is sort of like, it's invariant to the environment they're in. It's invariant to so many changing things in the world. So for example, if a flock of birds were flying together in a group, even though the wind is changing directions on them every single minute, they're still robust to those changes in their environment, and they're able to stay on course and stay on track to with their goal, which is basically flying to a certain location. All of the projects that have been built in the lab already are constrained to only working in a controlled lab environment. So what I mean by that is a swarm of robots could only work if they are on a very level surface, or if like the lighting conditions are a certain way. But collectives in nature are more robust to a lot of variations in their environment. The next step for this lab is to design and build swarm robots that are able to work outdoors, you know what I'm saying, that aren't restricted to a lab environment. So basically, we're trying to put together an outdoor robot that will then be used to create outdoor collectives. So why that's important is that swarm robots are very helpful when it comes to dealing with dull, dangerous, and dirty situations. So that's generally typically the rule for why you would build a robot to handle tasks that fall into any one of those categories. And so swarm robots would be really helpful for construction, not only here on Earth but also on different planets like Mars. And then swarm robots would also be helpful when it comes to natural disasters that happen here on Earth. Doing search and rescue with swarm robots would be really efficient and would probably save more lives. What's interesting about swarm robotics is that if you have a collection of robots that together must achieve some sort of task, if one of them or even a couple of them like get hurt or broken along the way, then it's like you have backups to still keep the swarm going and keep the entire collective on track to achieving the goal. You know what I'm saying? Swarm robotics is a very current topic in this entire field of robotics, and it's really cool to be able to jump into a research project that has to do with that. So that's basically the gist of why we do what we do. And I'm going to take you guys from the outside and bring you back in. Let's get this tour started. We are inside of Maxwell Dorkin right now, and this is the lab, so come on in. This is the view that you see when you first get in here. And I'm not sure if you're familiar with what a lab is. Like growing up, you know what I'm saying, in high school we would have chemistry labs or biology labs, but honestly a lab is just a place where groups of people, no matter the discipline, do research and do experiments. Now the experiments that don't necessarily have to involve chemicals or anything like that. Like our experiments are just testing the robots, so this is still a lab. So we got the whiteboards right here. Right now they have different parts of the project on them. Actually, let me take you over to one of the first things that we did. On the very first day, we kind of sketched out the what were we doing? We were sketching out some capabilities we wanted the robot to have. So this is, like, these are different people's sketches. Like, one person was focusing on the robot avoiding a pothole. Another one was focusing on barrier climbing. This is a decision tree that I made just real quick for a robot to retrieve an object. So after we kind of did some brainstorming there, then we made a concept map. And so our focus is to build an autonomous swarm robot. And basically all that is just a collection of robots that act together to accomplish a task. So this is our goal. And then we have different parts of that. So like hardware, you feel me, capabilities, design, and then software, and then this is like some stuff that can go in multiple categories. So once that was done, we went ahead and actually built the robot. So basically, robots come in different platforms. Like, not every robot that you've seen ever looks exactly the same. So platform just means like how it's shaped, okay? So we have 3 different kinds of robots. So here's one, and then here are the other 2. We named them. So this one is Raging Red, this one is Little Blue, this one is just yellow. And if the robots were dogs, this is what they would look like. This is Raging Red, Little Blue, and that's just yellow. Okay. And as you can see, all of them are kind of different. So after we built them, then we went ahead and designed what's called roll bars. So that just means that if the robot happens to fall over, all of the electronics that will be on it for this one, but that are on it won't get crushed, you know? We designed that in a software called SolidWorks, and then after that, one of our mentors took us over to the laser cutting room in another building, and then we just laser cut them and then attach them over here. After that was assembled, then we started to get the robots remote controlled. So we had a joystick. This is a drawing of the joystick, and one of our first steps was plugging in the joystick to a computer, typing in commands in the terminal to get the address of each button. You know what I'm saying? So when you press down a button, like, you'll see the address of it on the terminal. It'll print to the terminal, and then from there, you know that that when that button is pressed, like, that is the address of it. So then you can program motor commands so that once, for example, this button is pressed, like, it would like turn the motors or something. You know what I'm saying? So that was the first task that we did with controlling the robots. And then we started to turn our attention to the main sensor that we'll be using on the robot. So robots are comprised of 3 things. They're comprised of sensors, actuators, and algorithms. And so a sensor is just basically what is on the robot for it to take information in about its environment. So a sensor, it could have a sonar sensor, it could have a camera. There's so many sensors out there that you can put on a robot. And then actuators are what a robot has that allows it to interact with its environment. So some robots have like claws, you know what I'm saying? Our robots have wheels. So the motors are what the actuators of our robots are. And then the algorithm is the most valuable part of a robot system because it is it has the logic for how you take the sensor information, process it in order to like interact with the environment. And so when you see all these companies that are into robotics and they're making money by getting like government contracts and all that, it's because their algorithms for, you know what I'm saying, taking the sensor information and converting that to actuator commands are pretty darn robust. So we turn our attention to the sensor that we're using, which is the Intel RealSense R200 camera. And this camera has the capability to stream RGB, so a regular color stream, and then it also has a depth stream. So basically, it has a mechanism in here where it sends out a signal. Is it a laser? I don't know. I will get back to you on that. But it sends out a signal into the world, and then based off of how long it takes for parts of that signal to bounce back to it, it knows how far away things in the world are from it, okay? So we've got an RGB stream and a depth stream, and we're going to mount these onto the robots, and that'll be the main sensor that is used for every one of these robots. Now, we also do have sonar sensors, and we'll probably add those, but this is the main one. So once we turned our attention to the RealSense, we wrote code to take a screenshot of the video stream, so that would allow us to take pictures of basically take pictures of what can be seen from this camera when it's mounted on the laptop at this height, because this is kind of the height of where it'll be mounted on any one of these robots. Even though the camera is going to be mounted on these robots and it's going to be a continuous stream, so it can continuously get data from its environment and make decisions based off of that, getting an algorithm to work on an image for object detection will give us the understanding we need to then translate that into a stream. Because it's like a video is just a collection of all these images rapidly like succeeding each other. So if we know what to do with a single image, it gives us a concrete idea of what to do with the video stream, you know what I'm saying? So taking pictures is helpful because then we're able to do some image processing, so like detecting edges, and this is kind of the current module that we're in right now. Yeah, that's the whole lab. I usually sit right there. I have 4 other lab mates. They sit there, and like one sits over there with me, and we work together on code. Because this lab is kind of shared just a little bit, so we have another, I think he's a graduate student, he works there on his thesis, and then there's another girl that works over there in the corner, and that's the lab. Let me show you though some of the work that the people who work here year-round do. This is a case that displays their past projects. So this project, these robots are from a project called Kilobots, where it was a collection of over 1,000 robots that have sensors, and based on the pattern of a light that's projected from them overhead, they will self-assemble into that shape, like that. So alright guys, so over here are the Kilobots. Can you see them all lined up there? And this is that's the camera that takes footage. Usually during the week, there will be experiments that people in the lab run on them, so they'll usually be in some sort of formation here, but right now they're all over there. This is more work. said, this lab takes a lot of inspiration from nature, and honestly, all things that we do in computer science try to mimic either human beings or nature. So here we have pictures of ants that when they work together, they are able to build nests and even like bridges out of themselves. So it's about studying those types of behaviors and then programming them into robots. Let's see here. Over here is a tank that they are using to test out swarm robots that are underwater, and they kind of mimic schools of fish. Over here is the soldering station, and that's pretty much it. So we're gonna walk back over to our workspace. All right, home sweet home. So let me just walk you through how this project is kind of like laid out and what part we're in right now. So like I told you, the first thing that we did was build the robots, and then the next thing we did was hook them up with code that is able to control the motors based off of the addresses of different parts of the joystick. And then after that, we transitioned into the indoor autonomous stage. So it's like you work with one robot, and then what you learn from one robot, you transfer it to the swarm, you know what I'm saying, and kind of just like add little capabilities for each robot to talk to each other. So right now we're just working with one robot and getting it able to navigate indoors autonomously, and then we'll have a swarm that can navigate indoors autonomously, and then we'll have an outdoor robot that can navigate autonomously, and then we'll have an outdoor swarm that can navigate autonomously. And so right now we're in the stage of building an indoor autonomous robot, and inside of that stage of the project there are different mini projects. So like my partner and I are working on object detection and object avoidance, and there's a lot of computer vision that goes into that. And so the class that I took on computer vision has really been helping with the research and implementation of the code and all that. And the other subgroup is working on wall following. So just having the robot be able to follow the edges of a wall. And then all of this is going to kind of like knit itself together into having a pretty robust indoor autonomous robot. And from there we'll move on to doing the indoor autonomous swarm and continue on with the rest of those. It's really giving me a lot of understanding about what makes a tech corporation valuable, how research is done, because you know, like even though I'm inside of a lab, right, and this is an academic lab, I'm inside of a university, you know, corporations have research and development teams, departments. So you know, this whole experience, it's just like teaching me so many aspects of the work I'll be doing soon. I hope that gave you some information on what a lab is and kind of like what the work is that goes on in it. If you want to find out more about how you can get some research experience in a lab, definitely Google REU. And I'll see you guys next time. But before I sign off, let me just do a little lookbook real quick. So I got my Shade London. I really like Shade London because the quality, you know what I'm saying, of the fabrics, it's so good. Every single one of their pieces, the quality of the fabric, it's so good. So anyway, I got this green sweatshirt here. These are the supply shorts from Shade London too. Has little pockets that are like army aesthetic. And then I wore these with my pants. So thank you guys so much for watching. The next time I check in with you about lab related stuff, it'll probably be like a summer reflection about how the project went. So I'll see you soon. Bye bye.